Good afternoon. This is the instruction video about 6.18 classifying parallelograms. This is day 113. If you go to the assignment um, and you open it, something like this will pop up. And if you go to the very top to open with, you can open up a Google Doc uh, with the same information that you can actually type on. Once again, for all these videos, the yellow is where you can type in your answer. The blue, like right here, is where you're going to have to write your answer on a separate sheet of paper, and then take a photo and submit it with as part of your assignment. When you write on a separate sheet of paper, make sure you number it, like number 18 right here. And if it's helpful for you, you can always write all your answers on a separate sheet of paper, the yellow and the blue, and just submit that one thing. Okay, let's go on to the material in 6.18. So this is talking about classifying parallelograms. Specifically, we're talking about these three right here, rectangles, squares, and rhombuses. All three of these are types of parallelograms. Once again, the definition for a parallelogram is when two pairs of sides are parallel. So for example, right here is a parallelogram where you have the top and bottom side are parallel and the left and right side are parallel. Okay, so by the end of this lesson, you should know the definition for these three different types of parallelograms and understand their properties. So a rectangle is a parallelogram where the corners, all the angles are 90 degrees or right angles. A rhombus is a parallelogram except that the sides are all equal to each other or all congruent. A square has two different definitions. Either you could think of it as a rectangle where the sides are congruent, or a rhombus where all the angles are the same. Or 90 degrees. Okay, moving on. I want to talk here about nested properties. Nested properties is one way that helps you to think of the properties of these different types of figures. Let's give an example. Let's say that we're talking about humans. One category is humans, and we have one category are teachers. Sure. Okay, now all humans have blood in them. All humans breathe oxygen. So those are properties of humans. Now, properties of teachers, they all have to be licensed to teach. They all had to have gone through a teacher prep program. If we were to draw this, teachers are a type of humans, but humans are not a type of teacher. So if we were going to draw this in a sort of a Venn diagram type thing. So this right here would be your humans, and inside this big category is teachers. And all teachers, since teachers are a subcategory of humans, any properties that humans have, teachers also have. So for example, because teachers are a type of human, that means, and humans have blood and breathe oxygen, that means all teachers must also have blood and breathe oxygen. But it does not work in reverse order. Not all humans are teachers. So not all humans have a license to teach. Not all humans have gone through a teacher prep program. So that might help some people think of what properties these things might have. Since all three of these are parallelograms, they have any property that a parallelogram have, all three of them have. Since squares are a type of rectangle, and since squares are a type of rhombus, if a rectangle has a certain property, a square will also have that property. If a rhombus has a certain type of property, then the square will also have that same type of property. Okay, moving on. For number 1 through 11, in these blanks, you guys are going to put either always, sometimes, or never. For number 12 through 15, it's just a simple true or false. And after you answer number 1 through 15, use those to help you think of what properties do rectangles have, what properties do rhombuses have. Moving on to number 17, it is multiple choice. So just decide A, B, C, or D, which one is the one that is not true. For number 18, 19, here it gives you a statement, and you guys are going to prove it. Let's go through some of the vocabulary for 18. It says, here we're talking about a rhombus. So that is this figure right here, or my best drawing of a rhombus. All of these sides are equal to each other, because that is the definition of a rhombus. And the top and bottom side are parallel to each other. The top and bottom side are parallel to each other. And then the left and right side are also parallel to each other. Okay, so that's a rhombus. So here we're talking about a rhombus, and they're saying to prove that the diagonals are perpendicular to each other. So once again, the diagonals are the things that connects the corners. So in our picture of this rhombus right here, this would be one diagonal. This would be the other diagonal. And number 18 is asking you to prove that these diagonals are perpendicular to each other or meet at a 90-degree angle. So they're saying to prove that this will be 90 degrees. Okay. Number 19, here we're talking about a parallelogram. And it says, if this first part is true, if the diagonals are congruent, then show that the parallelogram is a rectangle. So if you have something like this, a parallelogram, and once again, remember, definition of parallelogram is just that the opposite sides opposite to each other are parallel. So AB is parallel to DC, AD is parallel to BC. So they're saying, if you have a parallelogram where the diagonals are the same or congruent, then show that the parallelogram has to be a rectangle, that the picture has to be a rectangle. So to help you along on this, one of your very first things should be when you create your proof table like this, one of your very first statements should be diagonals are congruent. And how do you know? Because it is given to you. So how do we know? What's the reason we know that? Because it is given to you in the question. And from there, continue until you get to the point where the very last thing you write is, well, the parallelogram is a rectangle. Okay, moving on to number 20. It asks you this question. So if you have a rectangle and you connect all the midpoints of the sides, then what type of quadrilateral would you have? So once again, let's say we have here a rectangle, okay? And it says that we're connecting all the midpoints. So basically all the points in the middle are getting connected. So let's say right here, that's the middle. Let's say middle, I'm gonna make this bigger. Say middle, 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 and middle. So what they're asking is if we were to connect all these midpoints. So I connect here to here, here to here, here to here, here to here. What would that shape be? So first answer what shape, and then prove that your answer is correct. Okay. So once you've answered these questions, submit your answers by taking a picture of whatever you wrote down. Plus, if you wrote anything in this piece of paper, submit this as well. All right. Hope everyone's doing well.